Hello, this video is going to be on chemical tests. I may sound a bit different, but that's because I have a new microphone. So these tests are things which need to be committed to memory, so I will be using obtusely designed slides to try help you remember. At least I hope they're obtusely designed, but we will see. So, welcome to the wonderful world of colour. That's cringy. No guarantee of wonder. The Bokbin's Law channel does not hold responsibility if the viewer does not find wonder in this video. All rights reserved. So, let's start with Group 2 Ions and all of the inorganic stuff first. So, Group 2 Ions, how do you test for them? You do flame tests, which the way you do them, as you can see on here, is the nichrome wire loop. You dip it in HCl to remove the contaminant, and then dip it in the compound. Put it in the Bunsen burner, and you will see for calcium,
brick red,
strontium,
red,
barium.
pale green,
Got that? Cool. Next, the ammonium ion. Well, first of all, NH3 ammonia gas is alkaline, which will turn red litmus paper blue. So if you make NH3 from the NH4 plus, then you can test for the NH3. So what you do is you add OH minus, sodium hydroxide, to NH4, which makes NH3, and then you get gas, and you can test for the gas. Group 7 ions, the halides. Now these, what you do is you can use silver nitrate to test for them. You add dilute nitric acid to remove any of the contaminant ions, and then silver nitrate. Chloride, bromide, iodide will form and precipitate, but fluoride will not. So, for the ones that will, chloride,
white,
bromide,
green,
iodide.
yellow,
Though chloride and bromide are both white-ish and so hard to tell apart. So how do we solve this? By doing an ammonia test with dilute and concentrated ammonia solution. So for chloride, it dissolves in dilute solution. Bromide dissolves in concentrated solution. Iodide, no. No, how about no? So, finally we move on to the other negative ions, such as the sulfates, for which you use barium chloride, which the barium ion in the barium chloride will react with the sulfate to make barium sulfate, which is insoluble and
white,
precipitate. For hydroxides, well, they're alkaline. You just pH indicator them. Yep. That's what the book says. Pretty simple. And finally, for carbonates, use hydrochloric acid to test for the carbonates. Remember, metal carbonate plus acid makes salt and water and carbon dioxide. So you get fizzing and you get a gas. The gas is carbon dioxide. If you bubble it through lime water, it turns
cloudy,
and that shows CO2 is present. If it doesn't, then you don't really have carbon dioxide then. Huh. Right, so that's all the inorganic ions and stuff. Now, we can also do the same for organic compounds, using testing for their functional groups. Let's start with alcohols, aldehydes, and ketones. So there's one test for alcohols and there's one test for aldehydes and ketones. So let's start with the alcohols test, to test for different order alcohols. Now, you may remember the oxidizing first and second order alcohols. This can be used for a test by using acidified potassium dichromate in a distillation apparatus with heat, gently. It'll turn
orange,
to
green,
with first and second order only. not third, where the first turns to an aldehyde, and the second to a ketone. So this tells us which of, say we have 3 mystery alcohols, this tells us which one of those is third order, but it doesn't tell the difference between first and second order. So how do we do that? Well, if you collect the product made from the distillation, and funnily enough, ta-da! You can test for aldehydes versus ketones. Now, you either add Tollens or Failing solution to the mystery substance, which is either an aldehyde or a ketones. Note that Failings comes pre-packaged like a Tesco meal deal, whilst Tollens you have to make yourself, because it degrades pretty quickly. Okay, so for Tollens, you add Tollens reagent to the substance and heat with a water bath because of fire hazard. This will do absolutely nothing with a ketone, but with the aldehyde it will form a... Now there's supposed to be word art here from 1994 saying...
Frozen mirror.
Got that? Right, just pretend it's there. Thank you. Or you can do the Failings reagent, which is
Blue.
and add that, heat it with a water bath like the other one, and with an aldehyde it will turn
Red.
So basically in the end ketones get shafted. Right, alkenes and carboxylic acids. Now for the alkenes, it's, remember GCSE, bromine water, which is
Brown.
and then you shake it and it'll form bromoalkane if there's an alkene, and it'll turn colorless. If it doesn't, it's brown, there's no alkenes. And finally, carboxylic acids, where you add a carbonate, such as sodium carbonate, as it suggests, or any other carbonate really. And remember the carbonate test from earlier? Well, this is literally the acid carbonate thing. It's the same observation of carbon dioxide, though this works for any acid, not just carboxylic acids. So you got to be sure it is a carboxylic acid. But in a pinch, if you can't remember that, just indicators. Only in a pinch, okay? Right, so that's the AS test out of the way, I think. So now we have to move on to... Ooh, this is scary. Look, the side's purple now because it's A2. Test 2, transition metal boogaloo. Right, shall we start? So there's 4 metal ions that you need to know for AQA, which is iron 2, copper 2, iron 3, and aluminium 3. So linearly, let's go through iron 2 first. Iron 2 in aqueous form is a green solution. Add some sodium hydroxide, it's a green precipitate which in air goes to brown. Add excess sodium hydroxide, no further change. Add some ammonia, it's a green precipitate which in air goes to brown. So I'm guessing no change. Add excess ammonia, there's no change. Add some sodium carbonate, it's the green precipitate of FeCO3. Okay, backwards. Copper 2. Now copper 2 in aqueous, copper 2 CuH2O6 is a blue solution. Copper 2 adds some sodium hydroxide, becomes a blue precipitate. Add excess sodium hydroxide, does nothing. Add some ammonia, becomes a blue precipitate. Add excess ammonia, becomes a deep blue solution. Add sodium carbonate, becomes a blue-green precipitate. Iron 3 is a purple solution, though it may look yellow-brown. Upon some addition of sodium hydroxide, goes to brown precipitate. Add some excess sodium hydroxide, there is no further change. Add some ammonia, it's a brown precipitate still. Add excess ammonia, there is no further change. Add sodium carbonate, it's a brown precipitate, and CO2 gas evolved. And finally, aluminium. Aluminium, AlH2O6 is colorless. Add some sodium hydroxide, this turns into a white precipitate. Add excess sodium hydroxide, this redissolves into a colorless solution. Add some ammonia, this becomes a white it stays a white precipitate from the white precipitate. Add excess ammonia, no further change. Add sodium carbonate, there is a white precipitate and carbon dioxide gas evolved. Now, that's everything on the table from AQA reactions of metal ions and aqueous solution. And that concludes the tests video on chemical tests. Thanks for watching.